Hi and welcome to the second lesson. Today we revise about periodic table. So here are the key objectives. We need to understand the structure of the periodic table. This will help us to predict the activity of elements. We will also learn a bit more about metals and non-metals, and we will state their differences, not only from the periodic table but relative to their activity. And then we will look in more details at group 1, group 7, and group 0, their activity and properties. And we will finish by looking at the differences between transition and group 1 metals. Let's get started with the first point, the structure of the periodic table. So if you don't have your own periodic table on hand, go and get it right now, because I would like you to get confident with one type of periodic table that maybe your teacher has given you, or that you have in your book. So the periodic table is divided into vertical sections, those are columns, and horizontal sections, those are the row. So each of these have columns and rows, and they have different meanings. So the columns is called the group number, while the row is the period number. There are 8 different groups, so we start with the 1 on the left hand side, 2, and then we go up to 8. This is often a group 8 or group 0, but let's stick to 8 because this number has a specific meaning. In fact, the group number tells us the number of electrons in the outer shell. While the row, the period number, would tell us the total number, so the number of shells or orbitals present in that element. So let's take a moment and think about, okay, let's take beryllium, for example, this element. Do you remember how to write the electronic configuration of it? So remember, we need to look at the number of electrons, in this case it's 4, and we need to think about how they're arranged. So we know that 2 are always in the first shell, just as we've learned the electronic configuration, and in this case there are 4 in total, so there are going to be 2 in the second shell. Now notice the similarities with its position in the periodic table. Let me change color here. So 2, the number of electrons in the first shell, corresponds to the first period. Think about these boxes as if they were little electrons that we fill up until we get to the element that we want. So the first period has 2 boxes corresponding to 2 elements, but this corresponds to 2 electrons. So first period, 2 electrons, like we write in the electronic configuration. And then a second period, because we go into the second row, and we're in group 2. Group 2 means 2 electrons in the outer shell. Okay? Let's try one more time. Let's try with aluminium. Can you try to write the electronic configuration and then link it to the position in the periodic table? Off you go. So notice how we have 2 electrons or 2 boxes in the first row of the periodic table corresponds to the 2 electrons in the first shell. Then how many do we have maximum in the second shell? We have 8. And how many do we have in the third? Well, we have group 3, so 3 electrons. There we go. So notice that all elements in the same group, they have the same number of electrons in the outer shell. This is important because it will tell us about their similarities. Remember, electrons is what determines their activity of elements because they are lost, gained, or shared to form chemical bonds. So, would you like to try one more? Let me clear it up. Use your own periodic table, and I would like you to write. So, write the electronic configuration, looking at the periodic table of magnesium. Magnesium is here. Try to do it looking at the periodic table and not at the number of electrons. So if you understand the structure, Yeah, you would be able to write the electronic configuration. 1 minute. So, 2 electrons in the first shell corresponds to the first period, comma, 8 electrons in the second one because magnesium has a full third period. 2 electrons because it's in group 2. There we go. Things get just a little bit more complicated if we have ions. So we said magnesium has an electronic configuration of 2, 8, 2 because it's in group 2. Okay, but what if is now magnesium 2 plus? Well, if you have the electronic configuration before, you can just think about, okay, it has lost the 2 electrons, right? So it would be 2, 8 easy. However, if you don't have this and you just have to think about from the position of the periodic table, look at the number of electrons, it's 12, right? So if it has lost the 2 electrons, it would have 10. So now we look at this element. In fact, ions have the same electronic configuration very often, or group 8 or group 0 element. Yeah, those we will see it very soon. They're noble gases. They have a full electronic configuration, full outer shell, so they're stable. That's why all elements chase that, but soon in more details in the next lesson. So looking back at the structure, 12 electrons. So now we look at 10. We write the electronic configuration of the element at position 10. 2 in the first, as usual. And now how many do we have in the second one? 8. There we go. I hope it's clear, and hold on to the final exercises and the workbook because we will look at more in more details the reactivity of elements.